Hello, my name is Patrick Farrell and I'm Senior Manager of Marketing for Simcenter Mechanical and Testing Solutions. It's been a year since I had the pleasure of talking to you all, and while 2021 was still a challenging year for many of us due to the ongoing pandemic, it was still also a productive year in terms of new development in simulation. But before I get into some of these new developments, let's talk about the challenges that many of you face in simulation today. One of the major challenges with simulation today, in a general sense, is that it's too slow. Typically, CAE analysts spend up to 80% of their time just on modeling processes alone. And even more frustrating is that this entire process is often repeated for every single design iteration, since it can be difficult to reuse the previous analysis model. A second challenge is that simulation in many organizations only takes place at the final validation stages of the development cycle. But to make simulation more effective, it must be used at all stages of development and by more than just simulation experts. Another obstacle today is that simulation engineers work in silos based off their functional domains, and each domain has historically required a specific set of software tools where user interfaces, processes, data files, and even vocabulary are all completely different. But physics don't happen in a vacuum, and in the real world, multiple physics are all happening simultaneously and have an impact on one another. So how can you predict product performance if you cannot accurately predict multi-physics interactions? More collaboration and integration among analysts and software tools is required to better predict how your products will perform. Simcenter 3D helps you conquer these challenges. As the most comprehensive, fully integrated CAE solution, you can work across simulation domains from a common engineering desktop. Simcenter 3D helps you go from CAD to CAE quickly while also keeping your simulation models in sync with the latest design. And as I mentioned earlier, the Simcenter 3D development team has had an extremely productive year, and I would like to share with you what's new in this latest release, Simcenter 3D 2022.1. New enhancements in Simcenter 3D help you improve simulation in 4 key ways. The first is model the complexity. Your products are complex, and you need to accurately simulate and predict performance by correctly capturing the right geometry, physics, and operating environment. The next is go faster. Increasing complexity can slow down your organization's ability to make the right decisions and meet project timelines. Therefore, engineers need to find a way to go faster despite the complexity that they work with. Explore the possibilities. Innovation requires exploration, which means you need to quickly explore performance for more design variants. This can be done by shifting simulation to the left into the design community, as well as automating and exploring more options for in-depth analyses. And finally, stay integrated. With increasing complexity, there are more opportunities for misalignment between the different teams in development. Simcenter 3D connects you with the broader Simcenter portfolio to keep you more integrated with the broader development process. So let's start with modeling the complexity. In this release, we have invested heavily in adding applications used extensively in the development of turbomachinery. Now, turbomachinery engineering is complex for a lot of obvious reasons. We have very complicated geometry throughout the cross-section, combined with many spinning bladed discs of different sizes, with fast fluid flow passing through the system, which undergoes extreme thermal changes. Fluid flow and heat also impact the structural integrity and dimensions of internal components, which adds yet another layer of complexity. And I haven't even yet mentioned the vibrations and dynamics that the system produces when operating at various speeds. So this is why Simcenter 3D has become a leading tool for turbomachinery analysts, since all of these analyses and more can be achieved through a single integrated platform. So let's start with rotor dynamics. And one of the main objectives of rotor dynamics is to properly identify the critical speeds of the system, which can then lead to very large vibrations and even system failure. Simcenter 3D offers a comprehensive rotor dynamics solution with efficient modeling capabilities that help you quickly go from CAD geometry to simulation model. Using Simcenter 3D, you can predict critical operational speeds and survivability of rotating systems, while accounting for gyroscopic effects and centrifugal loads in a wide range of situations. A major highlight in this release for rotor dynamics is the ability to account for the interstage junction between two stages of cyclic symmetry. When a rotating machine is made of different stages of cyclic symmetry, having potentially a different number of sectors in each stage, the interstage junction must be taken into account, like in this model with two sectors of cyclic symmetry. This new capability couples different cyclic fields at the interstage junction by adding different fundamental, higher-order harmonics. When looking at the results, we can post-process results for each harmonic on individual sectors, but we can also recombine the results on the full 3D model, taking into account the different harmonics together. Understanding the thermomechanical performance of turbomachinery is another challenging feat. Prototyping is far too expensive, yet traditional disconnected CAE tools are limited in the physics that they can simulate. The real world integrates complex physical phenomena in one environment. Your gas turbine simulations should too. Simcenter 3D integrates multiple physics disciplines within a single environment, which means you can create a whole engine model to see the complete engineering picture. Not only can you model and simulate multiple disciplines within a single environment, Simcenter 3D helps you to efficiently simulate the interrelated effects of heat transfer, fluid flow, and structural mechanics by streamlining multi-physics analyses. Today, engineers modeling the entire engine use what's called the whole engine model, which incorporates 2D axisymmetric and 3D components and thermal convective boundary conditions and ducts to represent the fluid. The key to getting the correct results is having the right heat transfer coefficients. This has been a challenge because using 3D CFD everywhere is prohibitively expensive, and capturing the correct heat transfer coefficients requires deep knowledge and experience backed by a multitude of tests and verification. In this latest release of Simcenter 3D, we have introduced a solution to add 3D CFD to portions of the model and support convection to axisymmetric meshes and connections to the 1D fluid network. This means you can connect 3D fluid simulation domains in a cyclic symmetric model defined with axisymmetric elements that are commonly used to model a turbomachine cross-section. Another common challenge for turbomachines is simulating thermal fatigue because temperature varies over the loading cycle. To calculate this today, many manufacturers use application-specific in-house simulation tools, which are difficult and expensive to maintain. Solving this problem also requires engineers to manually create many groups of material curves, which is tedious and takes up valuable time. As a result, engineers instead opt to over-design to account for worst-case scenarios, which means heavier components and more material. But new in Simcenter 3D is a time-varying thermal fatigue solution. This solution reduces modeling time by allowing you to read temperatures, stresses, and strains from FE results, and ultimately perform temperature-dependent fatigue analysis so that you can understand durability over real operational cycles. In summary, these new solutions in rotor dynamics, thermal multiphysics, and durability all help engineers more efficiently model and understand the complex nature and performance of turbomachinery. Engineers can use these tools to further improve turbomachinery efficiency for a more sustainable future. Now let's transition away from turbomachinery, and instead I want to talk about gear transmissions used in automotive, machinery, and other industries. Creating the complicated geometry and multi-body-based simulation models for gear systems is extremely time-consuming and difficult. But Simcenter 3D Motion Drivetrain, introduced a few releases ago, makes it much easier for you to quickly build and simulate complex transmission architectures. In this latest release, we have added a dedicated capability to simulate spiral bevel gears, often found in automotive differentials. This means you can perform accurate system-level NVH analysis on these mechanisms. So this can help you better understand the noise that these systems generate so that you can make your products quieter. Now let's move on to structural analysis, and more specifically, nonlinear analysis. Why is nonlinear analysis important? Nonlinear is better at capturing the true behavior of a component. While linear analysis is good and very efficient for some applications, it can't simulate what happens once you get into the plastic zones of your materials. And with more advanced materials like composites, linear won't be able to predict what's truly happening with your component. Many of you are already familiar with Simcenter Nastran, which has been used to solve linear structural analysis problems across most industries for decades. But did you also know that Simcenter Nastran can be used to solve nonlinear analysis problems? Well, it can, and it does it well. Siemens has brought together the Nastran technology that has been standard for more than 50 years and combined it with the advanced nonlinear capabilities in SAMSTEF to create the Simcenter Nastran multi-step nonlinear solution. Simcenter Nastran offers a complete set of nonlinear capabilities that will support most needed types of simulation. And in this latest release, we have invested to continue to improve the performance and overall capabilities of the nonlinear solution. One unique capability related to nonlinear analysis in this release is a new application dedicated to drop test simulation. Now, we all use lots of expensive devices that we can easily drop, and I'm sure there's a few of you out there that have had bad things happen when you drop your phone out in the parking lot. But the drop test simulation process is often laborious, and the engineers at consumer electronic device companies usually aren't experts in structural simulation. The new Simcenter 3D drop test application is a dedicated app that you can add onto Simcenter 3D, and it will show up as a toolbar right from within the Simcenter 3D environment. This application simplifies and streamlines the entire drop test simulation workflow from model setup to solve to results post-processing. Results templates and reports helps electronics engineers more easily understand the results of their drop test simulations so that they can quickly make the design modifications they need so that their devices can better withstand our clumsiness. Now let's move to the fascinating world of materials. Today we see new materials being introduced to the market at unprecedented speed. Nearly 70% of product innovation relates to material innovations. However, materials innovation is inefficient. Developing and certifying new materials is a long and expensive endeavor, costing some aerospace companies 10 years and $50 million. This is partially due to the extensive physical testing requirements, since engineers often don't understand what the failure mechanisms are in advanced new materials. And traditional simulation models don't account for advanced materials, which can vary at the microscale level. And material failure really starts at the microscale level and propagates out to larger scales. So to more accurately simulate and predict the behavior of advanced materials, Simcenter 3D Materials Engineering uses adaptive multi-scale modeling. In this latest release for Simcenter 3D Materials Engineering, we have tightened the integration so that multi-scale materials can be used in our Simcenter 3D Laminate Composites Modeler. This streamlines the multi-scale modeling process for laminate composites so you can more accurately predict performance for complex laminate structures. Another enhancement is the ability to homogenize permeability of porous structures. It's not feasible to perform CFD analysis on a material with microscopic pores. So instead, given a unit cell or microstructure model, you can homogenize the permeability accounting for the microstructure. You can then use that permeability data in larger scale models to further predict flow at the global scale to enable multi-physics workflows. Additive manufacturing is another new area where engineers are learning to grapple with complexity. New in Simcenter 3D is the ability to look at how the build plate can get distorted during the build process. 3D printing results in large residual stresses and strains in printed parts, and these stresses can result in excessive deformation in the build plate after the bolts are removed. A deformed build plate can cause problems with removing parts from the plate, and sometimes you might even need to scrap the build and create a new one. In this latest release, you can now define a flexible build plate which includes plate geometry, material, and thickness. During simulation of the build process, Simcenter 3D calculates the stress buildup in the plate bolts due to thermal expansion of the printer. Next, you can simulate bolt removal to see how the build plate will deform due to the residual stresses in the specimens. If the deformations are too large, you then need to use a thicker build plate or put fewer specimens on the build plate. The final topic in the subject of modeling the complexity is how do you know your simulations are accurately predicting reality? Correlation of analysis results with physical testing is a key task that helps ensure confidence in simulation. Simcenter 3D, along with our close interactions and connections with Simcenter Test, helps streamline the correlation process, and that's been available for many years for dynamic analysis. What's new in this release is the ability to now use Simcenter 3D's correlation capabilities for acoustics and vibroacoustics. This means acoustics engineers and NVH engineers can fine-tune their simulation models to real test data so that they can be confident that future simulations will more accurately represent what's happening in the real world. Ultimately, this can help NVH engineers meet targets for noise based on regulations, as well as requirements that your end customers will expect. Now let's move to our second pillar, to go faster. As I mentioned at the beginning of the presentation, the traditional simulation process is often too slow, and engineers get too bogged down in detailed modeling tasks. Simcenter 3D aims to eliminate the simulation bottleneck by providing efficient simulation processes to speed modeling so you can spend more time engineering. What's new for Simcenter 3D, specifically for aerostructures, is the ability to easily manage large numbers of load cases. Airframers need to manage thousands of load cases, and searching and filtering to find the critical load cases that really have the most influence over certain aspects of a design is a very tedious and time-consuming process. Often, airframe companies might be using in-house tools to do this filtering, but maintenance and upkeep for these tools is also costly. Simcenter 3D introduces load case filtering, which leverages CAD and FEM model interaction to reduce definition time. This new process allows you to quickly define filtering methods, extract loads and related geometry, which you can then further post-process from within Simcenter 3D to ultimately determine the final critical list of load cases. Outside of the airframe vertical, we've also added new capabilities that help all simulation engineers during the modeling phase, which can help you understand how changes you make to certain aspects of your model will ripple across and impact other parts of your model. For example, you can have your idealized part displayed in one tab, its FEM component in another tab, and the full FEM assembly in yet another tab. All of these are displayed simultaneously and synchronized. If you make a change to the geometry in the idealized part, that will then have a downstream impact on the FEM component in assembly, which you can now immediately see how those changes will ripple all the way through. This helps you better understand how the changes you make in the context of the entire model, so you're not having to manually switch between different views or parts. Solving speed also plays a role in the simulation bottleneck for some types of simulation, and solution speed is critical to getting results and decisions back to the design team quickly. So another way in which this release of Simcenter 3D helps you go faster, specifically for acoustics analysis, is through a new high-performance boundary element method with adaptive order, or BEM-AO as we like to call it. This solution helps you in a couple of ways. First, in terms of modeling, BEM-AO uses a very coarse mesh, which means you save time in the modeling process for your model. Next, the solution speed for BEM-AO is significantly faster compared to the standard BEM solution times, up to 10 times faster in fact. Now let's see how you can explore more possibilities. In my introduction, I outlined how simulation needs to happen at all stages of development, including the concept and design stages. To move simulation to the concept stage, We need to look at democratizing simulation so that it's not just a tool used by expert analysts. To help designers come up with new design concepts, NX Topology Optimization, which uses structural simulation of a package space to determine what the optimal geometry should be, has been available for a few years now. In this release, we have enhanced our topology optimization capabilities for designers to have an even tighter integration with the NX environment. You'll first notice topology optimization now has its own ribbon bar and navigator in NX. Designers use this to construct the optimization feature, run the optimization, and validate results. Topology optimization is now also a replayable feature in the part navigator tree, and so it will work just as a designer expects as any other feature in the tree would behave. This means it keeps upstream associativity, so anything that a designer changes that could impact the design package space gets updated. Downstream changes from the topology optimization feature also update to changes from the results. Another way to help democratize simulation and explore the possibilities that simulation can offer is by making simulation results more consumable for non-simulation experts. For those of you who are not acoustics engineers, do you even understand what this graph means? Acoustics is about sound. What kind of sound does this even represent? For this reason, last year we introduced the ability to auralize the simulation results so that you can actually hear the noise that the design will make in operation. In this latest release, we have extended the Auralization capabilities to support multiple tracks. Suppose you just simulated the sound of a loudspeaker in a free radiation environment. Now, how will that loudspeaker sound like when you actually put it in a car and combine it with the background noise from the engine, HVAC, wind, and road? Furthermore, can I still understand incoming calls or alert signals when the AC is on, or when I'm driving at high speeds with a lot of wind noise? With this new multi-track capability, you can now mix the contributing results and listen to the combined results to answer these questions. Listening to results helps designers and other stakeholders more easily understand the impact that design choices will have to the end customer experience without having to be an acoustics engineer. Finally, simulation doesn't happen in a vacuum, or at least it shouldn't. Simulation is just part of the development process, and it's critical that simulation stays integrated with that workflow. Accelerator Share is now available in Simcenter 3D for the Accelerator as a Service subscribers. Accelerator Share is a new way to integrate the development workflow across the Siemens Accelerator portfolio for small companies and for workgroups. This collaborative cloud environment works across NX, Simcenter 3D, Star CCM Plus, and many other tools, so that users of these tools can seamlessly share files and communicate results to each other. Analysts have always been looking for ways to leverage more powerful workstations or clusters to speed up their simulation or to run much larger simulations to increase accuracy. But connecting to a remote workstation or HPC cluster to submit and monitor your simulation jobs can be a real challenge. Exporting files, copying them to the remote machine, maybe modifying input files to make sure that they run on the new machine, or starting to solve with command lines. These all take time and can induce errors. So it's critical for Simcenter 3D to stay integrated with remote systems to make that process as simple as possible. The new Simcenter 3D remote simulation capability solves this problem. And you can now launch simulations remotely to any workstation running Windows or Linux on your network. You can easily connect to the server via the client in Simcenter 3D, where you can see in real time which runners are available to solve your simulation. You can then monitor the progress of an active solve right from your web browser to ensure that it's progressing properly. Once the simulation is over, you can bring results back to your Simcenter 3D workstation and then you're ready to post-process the results as usual. As part of the Simcenter portfolio, we continue to further integrate Simcenter 3D with other solutions in Simcenter. A new example of this is MF Tool, which transforms measurements obtained from a tire test rig into tire data that's used in Simcenter Tire. The tire data can then be used in vehicle multi-body dynamic simulations in Simcenter 3D Motion. So the new MF Tool integrates and streamlines the entire process of obtaining real tire data, which can then be immediately used in your simulations. So like I said, the Simcenter 3D team has had a productive year since I last spoke to you. That's a whole lot of new content, and these were only just the highlights. So there's even more within Simcenter 3D 2022.1 that will help you model the complexity, go faster, explore the possibilities, and stay integrated. Before I leave, I also want to remind you about the Simcenter Community, which is a forum where you can discuss topics on using Simcenter 3D, Simcenter Nastran, and all of our other Simcenter products with the other customers and users of those products. It's a great source of information, and if you haven't signed up already, I highly suggest that you check it out. Another great source of information for Simcenter 3D customers is Support Center from our support team. You may have even recently seen Simcenter TV, which has been great at highlighting tips and tricks and showing you how you can use Simcenter 3D and even other Simcenter tools for a wide range of applications. And lastly, if you're new to Simcenter 3D and are curious to learn more, I also suggest that you give it a try with our 30-day free trial, which is available at the URL shown here. You'll also see it in the YouTube description shown below. It's an opportunity for you to go out there and see how Simcenter 3D can help you engineer innovation. So with that, I want to thank you for your attention and have a very wonderful 2022.